This lesson is on classifying quadrilaterals in the coordinate plane. So we can use the points that make up a shape and the slope and the distance to tell us what shape that is. And we have one big chart here. The first thing we're going to check is to see if it's any type of parallelogram by looking if the opposite sides are parallel. So we're checking if slopes of opposite sides are equal. That's our very first step. If the opposite sides are parallel, we're going to move on. If we don't have two pairs of opposite sides that are parallel, it's not a parallelogram. If there's one pair that matches, it's a trapezoid. If we don't have any pairs that match, we're just going to call it a generic plane quadrilateral. So if we did have two pairs that were parallel and we're moving on, we're going to continue to check the slope of the lines, but now we're looking to see if there are right angles. So to check if there are right angles, we're going to check the consecutive sides if they're perpendicular. So we're going to check if slopes of consecutive sides are opposite sine reciprocals. That still won't tell us what our shape is. If our consecutive sides are perpendicular, it could either be a rectangle or a square because both of those shapes have right angles. If they were not perpendicular, it could either be a rhombus or a parallelogram because neither of those has right angles. So the last thing we're going to check is the distance of all of our sides. To check if all sides are congruent, we're going to check the lengths of the sides, and we're going to check with the distance formula if all four sides are equal. So if we did have perpendicular lines and all sides are equal, that would be a square. If we had perpendicular lines but all sides were not equal, that's a rectangle. If we didn't have perpendicular lines and all sides are equal, that's a rhombus. And if we didn't have perpendicular and they were not all congruent, it's a parallelogram. Basically, I know this got real tiny real quick. Squares, perpendicular and congruent. Rectangle, perpendicular, not congruent. Rhombus, not perpendicular, but congruent. And parallelogram was not perpendicular and not congruent. These are the two questions we're going to ask for each of our shapes, and all four have a different answer once we combine the two questions, right? This was a yes, yes. This was a no, no. This was a yes, no. This was a no, yes. So let's try some. And the first thing we're going to do is they're telling us we're using quadrilateral STEL. So we're going to draw it. Right, nice four-sided figure. And when I label it, I'm going to continue going clockwise all the way around. So I can't go STEL, I have to go STEL. The sides that are across from each other would be ST with LE. But also SL and TE. So that was ST and EL. That was SL and TE. The consecutive sides are sides that meet somewhere. So LS and ST meet at S. ST and TE meet at T. TE and LE meet at E. And then SL and LE meet at L. So looking at our first example, ST and EL were opposite. TE and LS were opposite. That's what we said right here. And then one that happens right after the other is considered consecutive. So the first thing I'm going to check is how many pairs of parallel sides I have. And I'm looking at opposites. So the 4 is opposite the 4. Those are equal, so they're parallel. The 2 is opposite the 2. Those are equal, so it's parallel. So we do have two pairs of parallel sides. That means we're going to answer the next two questions. If we said 0 or 1 here, we would cross these out and go straight to putting our answer. So the next thing we're asking is about the consecutive sides are either perpendicular or not perpendicular. So consecutive are one right after the other, the 4 and the 2. I'm looking to see if these numbers are opposite sign reciprocals. They are not. So we're going to say not perpendicular. No right angles. So we can cross off rectangle, we can cross off square because both of those have right angles in them. And we can get rid of trapezoid because we had two pairs. Now we're going to check if all sides are either congruent or not congruent. So that's my distances, and I'm going to look at all of them together. All four of these numbers are the same, so we'll say congruent. So out of the remaining shapes, parallelogram or rhombus, the one with all sides being the same was the rhombus. And that's how we'll answer these questions. Let's do a few more examples. Example 1B. Checking opposites, 3 with 3, 1/3 with 1/3. So we do have two pairs of parallel sides. My consecutive sides are reciprocals, but not opposite signs. So this is not perpendicular. So again, I can get rid of the rectangle and the square because I don't have right angles. When I look at my distances, 12 and 9 are not the same. So we're going to say not congruent. So if all sides are different, it's not the rhombus, it's the parallelogram. Another one together. The 3/4 and the 3/4 match. -4/3 and -4/3 match. So we have two pairs of parallel sides. My consecutive sides, I have +3/4 and -4/3. So those are opposite signs and reciprocals. So these are perpendicular. So it does have right angles. It's either the rectangle or the square now. And then I'm going to check my distances. All four of these are equal, so we could say that they're congruent. So between the rectangle and the square, the one with all sides the same, that's the square. All right, example 1D. I have 1/3 matches with 1/3. I have undefined does not match with -4/3. So only one pair of sides was parallel. So I can get rid of both of these questions because when only one pair is parallel, it's a trapezoid. If you wanted to be more specific, we can check to see if the sides that are the legs are equal, and we can call it isosceles, but that's okay. We could also just stop here and say that it is a trapezoid. So there are two for you to do. This is the first one. Feel free to pause now or pause after I show you the second one. Answers are posted on Google Classroom. So for our problems where we have to create our own table, we know it's quadrilateral ABCD. So my sides, I'm going to go in order. AB, then BC, then C to D, and then D is going to connect back to A. So that's how I'm going to make the list over here on the side of what the sides are. Then I'm going to find my slopes. So remember, it's change in Y over change in X. -2 minus -4. I'm going to cut a step and write plus 8 minus 9. So that's 2 over -1, which is just -2. I'm going to jump ahead here to CD, -7 minus -5, so -7 plus 5, 3 minus 2, so it's -2/1, which is -2. So far, we have at least one pair of parallel sides. Let's do the slope for BC and DA. So that's going to be -5 minus -2 turns into a plus 2 minus 8. So this is a -3 over a -6, and that reduces to be a positive 1/2. For DA, we have -4 minus -7, so -4 plus 7. We have 9 minus 3. So this is 3/6, which is positive 1/2. So we had one pair of parallel sides, and now we got 1/2 and 1/2. So we have two pairs of parallel sides in my picture. That means I do want to answer the next two questions, the first of which is asking about consecutive sides. So my reduced slopes were -2 and positive 1/2. Those are opposite sign reciprocals. So my consecutive sides are perpendicular. So immediately we've crossed out trapezoid because there were two pairs. And now that we have right angles, we can cross out rhombus and parallelogram. The next part is asking about if the sides are congruent. Ooh, lost that for a second. If the sides are congruent. So we're going to have to do the distance formula. So just a refresher, our slope formula that we're using is y2 minus y1 over x2 minus x1. The distance formula can be written like this. Which means if I've done my work for the slope, and let's say I ended up with 15/10 as my slope, even if I reduce it to 3/2. If 15/10 was my slope, 15 is y2 minus y1. So we can plug it directly in here like that. And 10 was x2 minus x1. So that can go directly there. So once our slope is done, we can use the original numbers and plug them in for our distance formula. And that's going to save us a lot of time and a lot of headache. The only issue is if you did the slope wrong, now we're going to get the distance wrong too. So for AB, the slope was 2 over -1. So in my parentheses, we're going to have a 2 squared plus a -1 squared. 2 squared is 4. -1 squared is 1. So this is the square root of 5. For BC, I'm going to use the -3 and the -6 because those are my original numbers. So -3 squared plus -6 squared. 3 squared is 9. 6 squared is 36. Adding them up, we get the square root of 45. I could probably already tell what the shape is going to be. I'm going to keep doing my work just in case. So this is -2 squared plus 1 squared. 4 plus 1 is 5. And this is 3 and 6. So 3 squared plus 6 squared. 9 plus 36 is 45. So now looking at my distances, I'm looking to see if all sides are congruent. These numbers are different, so all sides are not congruent. So between the rectangle and the square, the rectangle is the one without the sides congruent. All right, let's do some more. Example 2b. So this is QRST. So my sides will be QR, RS, ST, and then T back to the beginning at Q. So we're going to have -5 minus -7 over 1 minus -2. Turns into 2/3. We're going to have -7 minus -5 over 4 minus 1. It's -2 over 3. We're going to have -9 minus -7 and 1 minus 4. -2 over -3 is 2/3. And for TQ, we have -7 minus -9. -2 minus 1 is 2 over -3. So looking at the first and the third, they're both positive 2/3. Second and fourth, they're both negative 2/3. So we have two pairs of parallel sides. That gets rid of trapezoid. Checking the consecutive sides. 2/3 and -2/3 are opposite signs, but they're not reciprocals. So this is not perpendicular. We can get rid of square and rectangle. My distances. I'm using a 2 and a 3 here. So 2 squared is 4, plus 3 squared is 9, 4 plus 9 is 13. We're going to use the -2 and the 3 for the next one. So that's 4 plus 9, that's square root of 13. We're going to use the -2 and the -3. That's 4 plus 9, or 13. And for this one, we're going to use the 2 and the -3. 4 plus 9 is 13. So all four distances were equal. All sides are congruent. So out of parallelogram and rhombus, that makes this a rhombus. So the last two are check-ins. This is the first one that's available for you. And then I'm going to show you the next one. This is B. So the answers are posted on Google Classroom. That is the end of classifying using coordinates.